Welcome to Bite-Sized Data Science. In data science, data is everything. There are many reasons why you may be looking for data. In this video, we talk about how you can search through a catalog of over 40,000 datasets programmatically. In a previous video, I've used data on car crashes from the city of Chicago. You can go to the website data.cityofchicago.org, navigate through the 16 categories, and download a file in one of the formats provided. Navigating through the City of Chicago website to find the over 400 datasets is very time-consuming. Then what about datasets from other cities, states, and government agencies? How can we find them? This is where Socrata comes in. Socrata was founded in 2007 and was acquired by Tyler Technologies in April 2018. Socrata develops and operates a government domain-specific, cloud-based data-as-a-service platform. The assets available through the Socrata API include more than just datasets, but we're focusing only on datasets here. Let's jump into a notebook and see how we can explore the catalog. We are using the IBM Watson Studio environment with Python and the Pandas data frames. You can create a free account using the URL provided in this video description. The Socrata Discovery API is accessed through HTTP request. We will access the information anonymously. This means we only have access to public data. The first thing to note is that there are currently two URLs used to discover domains containing assets. They roughly represent the Americas and Europe. We'll use both, but focus on the Americas one in more details. The assets available are kept in domains. Look at domain as the organization that owns the assets. For example, data.cityofchicago.org is a domain that owns over 400 assets. The first thing we want to do is find out how many domains and how many assets are available. Through some quick manipulation of the query result, we can find out the answer. We have 277 domains that include over 130,000 assets. Note that new assets are added regularly. We can also quickly find out which domain have the most assets. We see here that data.nasa.gov has the largest number of assets with over 17,000. Similarly, we can do the same thing for the European assets, a lot fewer domains and assets. It's now time to focus on datasets. We can use the API to limit the return values to datasets. Note that, by default, the API returns only 100 records. The pagination parameter limits us to 10,000 records, so we have to use a scroll ID parameter and loop over multiple queries to make sure we get all the records. We end up with over 35,000 records, each with 34 attributes. Just like for any new datasets, we need to explore it to become familiar with it and understand its characteristics. The Discovery API documentation gives us some information, but there is nothing like doing exploration, just like we would do for any other datasets. Also, we need to find out how the JSON_normalize function converted the data. Just by looking at the first few records, we see that we have attributes that are list of dictionaries, strings, numbers, and timestamps. By the way, not all the attributes are listed in the output of the head command. We can see ellipses in the output showing that some columns are skipped. How many domains do we have and how many datasets do they include? We see that some domains do not include any datasets since the number we got here is lower than the number we had in the domain query. We can get an idea of which domain have the most datasets, but it is interesting to also see which ones have the least. Should we get rid of the domains with only a few datasets? Probably not. It may simply mean that they are just starting to make datasets available, and the datasets they currently have may be what we're interested in. If we look at the date the datasets were created and updated, we can determine if these datasets are active or not. For completeness, we do a quick check on the European URL. we find over 5,000 datasets. Note also that the number of attributes is different from the Americas catalog. Let's go back to the Americas catalog. How do we navigate it? We need to find out more about the 5 fields that relate to categories, tags, and metadata. The classification.categories are found in roughly half the records, and we find 13 categories. This can be useful, but since more than half of the records don't have categories, a search on that could miss interesting data. The domain category attribute has over 800 different values here in at least 2 languages. The domain metadata covers most of the records. It also includes over 800 different keys in at least 2 languages. It is not obvious if the keys are somewhat standardized, but it could be worth additional exploration. The domain tags also cover most of the records, but has a lot of different values. Using the top tags could be useful. Finally, the classification tags are used so infrequently that they are useless. There is other exploration we can do. Look at the number of entries for each attribute, find out the names and types of the attributes in each dataset, search datasets based on names and descriptions, for example. Other important ones are the date created at and date updated at. Looking at the types, we see that these attributes don't have the proper type. We can do more complex searches, such as the search listed here, where we looked for datasets in the data.cityofchicago.org domain that include crash in the description. The Pandas Data Frame API supports all sorts of search, including search on name and description. Multiple search criteria can be part of one query. You could then retrieve only the subset of the datasets you are interested in. You may want to save the catalog into your own repository and update it regularly. You could even process the data and write it in multiple tables in a relational database. This way, you could use SQL to search for the desired datasets. The notebook used here includes some simple commands to save the data into a CSV file. And since we are in the IBM Watson Studio environment, we also need to save the resulting files in a cloud object storage, as the code shows here. Now you know how to search a catalog of over 40,000 datasets. In the next video, we'll look at how we can retrieve the dataset information and read a dataset into our notebook environment. See you next time on Bite-Sized Data Science.